Okay, this is problem number 6 from section 3-4. And the first thing we have to do is we've got some data that represents the miles per gallon of a random sample of cars with the same cylinder and engine. So we're asked to compute the z-score corresponding to the individual who obtained 38.3 miles per gallon. So a z-score as a concept is just a way to tell how many standard deviations above or below the mean a particular data point is. So if we want to know what the z-score of 38.3 is, we have to know both the mean and the standard deviation of the data to see, right now we don't even know if it's above or below the mean, right? So to do that, we can just use StatCrunch real quick, load the data up. Okay, from here we've got all the miles per gallons in this column, so we just do summary stats, and I'm gonna the data's in columns, so variable 1, that's the name of the first column, and I just want the mean and the standard deviation. By the way, I hit control to be able to click that standard deviation and hit compute. So this now gives me the mean and the standard deviation of the data. I can then see how many standard deviations above or below the mean this is. Now let's see, this is 38.3. That looks like it's below the mean. Anything that's below the mean is going to have a negative z-score, right? Because it's going to be standard deviations below the mean. Anything that's to the right or over 38.9 is going to have a positive z-score. If you have a data point that's exactly the mean, that would be a z-score of 0, right? Okay, so let me take you into my Scratch work as I work through this. You see these aren't the nicest numbers, 38.9, all these decimal places, and you'll see how we're going to handle that. So like I said, I just used StatCrunch to find the mean and the standard deviation. Notice I rounded them here just so that's nice to write. And we want to find out how many, this is standard deviations, right? The sigma is 38.3 below the average. And so what I do is I take the data point they gave us, 38.3, I subtract the mean, and notice I've done the unrounded one, or at least rounded to a bunch of different decimal places. This is all the numbers that StatCrunch gave us in their mean. That's important not to lose that information. And then divide it by the standard deviation with all those decimal places. And when I divide that, I get a long number, but that rounds to 2 decimal places to negative 0.17. Okay, which is what they've asked me to round it to 2 decimal places. Okay, so that explains this part right here. It says in part A, the z-score corresponding to the individual is negative 0.17 and indicates that the data value is 0.17 standard deviations below the mean, right? That's why it's negative, because it's below the mean. Okay, now for the second part, determine the quartiles. This is really nice on StatCrunch. You can just go to stats, summary stats again. You can also, just from this, hit edit. And then reselect. Instead of selecting mean and variance, we want to select what? We want to select Q1 and Q3. And Q2 is actually the median, right? So now I compute that, and it's going to give me the quartiles. So quartile 1 is just 36.8. Okay. That's good. Remember what a quartile is. It really divides the quantity of data into four parts. So 25% of the data points, right? Which would be about, let's see, we have 24. A quarter of 24 is 6, right? So 6 data points are going to be below this. The median divides the data in half. So half are going to be below it, half above for Q2. Whoops, sorry. I accidentally stuck in Q3 instead of the median. So that's 38.6, my bad. Hit excellent. And then 41 for Q3. And 41 is the number that 25% of the data points are above, 75% of the data points are below. Okay. Now the part C asks us to find the interquartile range. And again, I can use StatCrunch actually to do this. So I'm going to go into edit, and I want to know the IQR. The interquartile range is just the distance between quartile 1 and quartile 3. So it really covers the middle 50% of the data. 50% of the data points are going to be between that. It's a span, it's a length that between the quartile 1 and quartile 3. So we're going to need to know this because, just to answer this question. So the interquartile range, let's see, it's got some other stuff here. It's the range of observations between the lower and upper fences. Not quite true, right? That's something different. Interquartile range is the middle 50% of observations in the data set. And yes, that's true because it covers between quartile 1 and quartile 3. Okay. Now determine the lower and upper fences. So the lower and upper fences are a way to identify any extreme values in the data set. And the way that it's defined is that if a point is 1.5 times the IQR above or below quartile 1 or quartile 3, then it's considered a really extreme value, okay, an outlier. So first what we need to do is calculate the fences, which are what number is 1.5 below quartile 1, what number is 1.5 times the interquartile range below quartile 1, and what number is 1.5 times the interquartile range above quartile 3. I didn't say that so well, but here I've got it nicely written out here. So the lower fence is just quartile 1 minus 1.5 times the IQR. Now in part B, we calculated the quartile 1 and we just calculated the interquartile range. So we get the lower fence at 30.5. And we get the upper fence, let's see. This is quartile 3 plus, right, 1.5 times the IQR. And we calculate that and we get 47.3. So I haven't found a real quick way that StatCrunch gives this to me yet. You still have to calculate this out by hand, but it's not a bad calculation. Okay. Now we need to use this to identify any outliers. So what we can do is look over the data and see if any numbers are below 30.5. That would be an outlier on the low end. No. Okay, I don't see anything. And anything above 47.3, that would be an outlier on the high end of the data. And do I see anything? Oh yeah, the last data point, 49, is above 47.3. So that should be our outlier. I'll just return. There we go. Okay. So that's this problem. I also want to show you a cool thing to really quickly identify the outliers. Like if they don't make you find the fences and everything, if you do a box plot, it actually gives you a couple of cool things. Use fences to identify outliers, draw boxes horizontally. And let me show you the graph of this. So the cool thing about this is it shows you which point's an outlier, right? Without you really having to look through the data table, which is nice if you got, 24 data points here isn't bad, but if you got a ton of data, it really helps to have the computer find it for you. Another nice thing you do is you notice that it gives you most of the other information here. Like if you hover over the boxes, right, this is the median right here. and it tells you what the median is, tells you what quartile 1 is, quartile 3 is. It even tells you the IQR. So just something to know is a kind of a quick way to do some of this stuff. So I hope that helps a little bit.